Welcome to lecture series in physics. In this lecture series, we are discussing about gravitation and its related phenomenon. In this lecture series or in this session, I will be doing a problem related to gravitation first, then I will be discussing the following topics. First, I will be discussing the Kepler's law of planetary motion regarding gravitation, and the second topic I am going to discuss is deduction of Newton's law of gravitation, determination of gravitation constant by Boy's method, gravitation field and gravitation potential, and gravitation potential for a spherical shell. First, I will solve a problem related to gravitation. I will read out this problem. Show that the mass of the earth may be compared with that of a sun from a knowledge of the time periods of the earth round the sun and of the moon round the earth, together with the radii of the respective orbits taken to be circular, which is given by mc by ms is equal to rm by rc the whole power 3 into wm by wc the whole square. So, this is the problem. So, we should try to solve this problem by having this following data in the mind. So, let us say ms and me, let us say ms and me be the masses of the sun and the earth respectively. So, let ms be the mass of the sun and let me be the mass of the earth. So, let us say let re is the radius of the earth orbit around the sun and let omega e be the angular velocity of the earth. So, these are the data. I repeat once again, ms denotes the mass of the sun and me denotes the mass of the earth and re denotes the radius of the earth and we denotes the angular velocity of the earth. So, having these data in the mind, we will apply Newton's law of gravitation for this formula. So, when you apply, we will have, according to Newton's law of gravitation, we have F is equal to, it is Gmm by r squared. So, where G is the gravitation constant, m is the mass and small m is the mass and r is the radius. So, based on this Newton's law of gravitation, F is equal to Gmm by r squared, we will solve this. Therefore, I can write G into ms into me divided by re squared is equal to, it is a centripetal force. The centripetal forces, it is me, re and omega e square. So, therefore, from this we will calculate what is Gms. So, from this we can have Gms is equal to, it is re power 3 and omega e squared. So, similarly, we can write for the earth, it is G me and divided by rm squared is equal to, it is rm omega m square. So, therefore, where denotes the mass of the moon and rm denotes the radius of the moon's orbit around the earth and omega m is the angular velocity of the moon. So, therefore, from this we will calculate what is Gme. So, Gme is equal to, it is rm cube dot omega m square. So, we have calculated me, from this we also calculated Gme. So, from this T equation we will calculate what is me by ms. So, me by ms is equal to, it is Rm divided by RE the whole power cube into Wm divided by We the whole square. So, let Te represents the time period of the earth and let Tm represents the time period of the moon. So, therefore, we can have omega m divided by omega E the whole squared is equal to it is T by Tm the whole square. So, from this I can write it is Me by Ms is equal to Rm by Re the whole power 3 into Te by Tm the whole square. So, thus knowing Rm, Re, Te and Tm, the mass of the earth can be compared with that of the sun. So, this is the final statement. The final statement says that Me by Ms is equal to Rm by Re the whole power 3 into Te by Tm the whole square. So, using this we can solve this problem. So, these are the statement regarding Kepler's law of planetary motion. So, the first statement says that every planet moves in an elliptical orbit around the sun being at one of the foci. So, which means that the sun is at the center. So, based sun at the center, all of the planets revolve around the sun. And how would the planets revolve around the sun? All the planets revolve around the sun with the sun as the center in the form of an elliptical orbit. It is not in circular orbit, it is in the form of elliptical orbit. And the second statement is the radius vector drawn from the sun to a planet sweeps out equal areas in equal intervals of time. So, that is to say that in other words the aerial velocity of the radius vector is constant. Or what do you mean by the aerial velocity? It is the rate of change of acceleration, or it is a dA by dt is a constant. And the third important parameter is the square of the period revolution of the planet around the sun is proportional to the cube of the semi major axis of the ellipse. If t is the time period of the planet and a is the semi major axis, then mathematically I can write t squared is proportional to a cube. And we will deduce Kepler's law of planetary motion from Newton's law, or it is the deduction Newton's law of gravitation from Kepler's law. So, in order to deduce Newton's law of gravitation from Kepler's law, let us consider two planets. Say the two planets may be a Jupiter or a Pluto. Let the mass of Jupiter be m1 and let the mass of the other planet or Pluto be m2. Let r2 be the radii of the circular orbits. Let t1 and t2 be the periods of revolution around the sun. So, therefore, the centripetal force acting on the first planet is given by it is mr omega squared, or it is f1 r1 omega squared. So, f1 is m1 r1 omega squared, or I can write m1 r1, this is m1 r1. So, it is retained as m1 r1. So, in place of omega, the formula for omega is 2 pi into nu. So, therefore, omega is 2 pi. In place of nu, I can write 2 pi into 1 by t, or it is omega is equal to 2 pi by t. So, this omega is 2 pi by t is substituted over here and it becomes 2 pi by t1 the whole squared. And similarly, the centripetal force acting on the second planet is F2 is equal to it is m2 into r2 into 2 pi by t2 the whole squared, it is replicated over here, that is F2 is equal to m2 into r2 2 pi by T2 the whole squared. So, you divide the two masses F1 by F2. So, F1 by F2 is equal to m1 r1 by m2 r2 into T2 by T1 the whole squared. So, but according to Kepler's third law, we can write F1 by F2 is equal to m1 by m2 into r1 by r2 into r2 by r1 the whole cube, which can be written as m1 by m2 into r2 by r1 the whole squared. So, that is, we can say that the force on the planet is directly proportional to the mass and radius, or F is directly proportional to m divided by r. So, in other words, we can say that the force is proportional to mass of the planet. And also we also observe here is that the attraction between the planet is mutual, and therefore, the force is also proportional to the mass of the sun. Therefore, hence I can write F is directly proportional to F m divided by r2 or r squared, and F is equal to g mm by r squared, which is Newton's law of gravitation. And let us now discuss another experiment. So, this experiment is known as Boy's experiment. So, this Boy's experiment is used to determine the gravitation constant. So, what is the value of gravitational constant? The value of gravitation constant G is equal to, it is 6.627 into 10 power minus 11 nm squared kg power minus 2, and this value of gravitational constant can be determined by a simple experiment known as Boy's experiment. So, for the determination of the gravitational constant, we have the apparatus. So, this is the apparatus for gravitation constant, and the apparatus consists of two axial glass tubes T1 and T2. So, where are the two tubes T1 and T2? So, this is the tubes, T2 is here and T1 is here. So, therefore, you have two tubes T1 and T2, and which is mounted on a platform providing with the leveling screws, and these are the leveling screws given in the diagram, and the inner tube T1 is fixed, while the other tube T2 can be rotated about the common axis. So, from this diagram we can say that this T1 tube is fixed and the T2 tube can be rotated along the common axis, and a small mirror RS is suspended in the inner tube by a fine quartz fiber F from a torsion head. So, we can have a small mirror RS here, it is shown in the diagram, and from the two ends of the mirror, two gold spheres A and B are suspended such that spheres are at different depths below the mirror. So, these are the C and D are the two gold spheres, and these two gold spheres are at different heights. When you look at this diagram, you can see that the spheres C and D are at different heights. So, in the outer coaxial tube T2, there are two large lead balls C and D are suspended from its revolving lead such that the center of C is in level with that of A, and we can also say that the center of D is in level with that of B, and the two lead spheres as a safeguard against damage in case they should fall accidentally. So, the experiment is performed. How to perform the experiment? The experiment is performed by rotating the outer glass tube until large lead spheres lie on the opposite sides of the two gold balls, so as to exert the maximum moment on the suspended system. In this position, the angle through which the mirror RS turns is maximum. So, therefore, the outer glass tube is then rotated so that the lead spheres now lie on the other side of the gold balls in an exactly similar positions, producing the greatest deflection, and the mean of these two observations gives the deflection of the mirror theta, and you have arrangement, lamp and scale arrangement, which is used to measure theta. Therefore, we will calculate what is the force of attraction between the spheres A and C. Therefore, the force of attraction between the spheres A and C can be written as, that is, the general formula for force of attraction is F is equal to, it is Gmm by R squared. So, in place of G, I am writing it as G, and mm is retained as mm, and the R is the distance. In place of R, I am writing it as AC the whole squared. And similarly, what will be the force of attraction between the spheres B and D? So, the same formula is repeated again. Gmm is written here, and in place of R, the distance between the spheres B and D is written as BD the whole squared. And from the diagram, it is clear that, so from this diagram, it is clear that AC is equal to BD. So, this is B, this is D, this AC and BD are equal. So, since AC and BD are equal, the two forces are equal, parallel, act in opposite direction. So, whenever two forces act in opposite direction and if they are parallel, then we can say these forces are in couple. So, therefore, we will find out what is the moment of the deflecting couple. So, the moment of the deflecting couple is Gmm by AC squared into 2L is equal to, in place of AC I am replacing with D, therefore, it is Gmm by D squared into 2L, where this 2L is the length of the mirror strip RS and AC is equal to D. So, here RS is the mirror strip, this length is D, this length is 2L, and AC and this AC value is D. The deflection of the mirror under this couple is resisted by the torsion or twist set up in the suspension fiber. Therefore, what will happen is, after the finishing the experiment, the mirror strip will come to rest due to, or when the deflecting couple due to the gravitation pull is balanced by the restoring torsional couple set up in the suspension fiber. And let C be the torsional couple per unit twist, then for angular deflection theta, the restoring couple is C theta. So, therefore, in equilibrium position, I can write Gmm by D squared into 2L is C theta. So, from this we can calculate G, that is, we have it is Gmm by D squared into 2L is equal to C theta, or I can write it is 2L mm by D squared is equal to C theta by G. From this we can calculate what is G. So, using the arrangement of the quartz fiber and the mirror strip with the gold balls as a torsional pendulum, the time period T is found. Therefore, we know that the time period is 2 pi root of I by C, where I is known as the moment of inertia and C is the couple per unit twist. Therefore, the results obtained in these experiments are very accurate, and the value obtained for G by Boy's experiment is found to be, it is 6.67 or 6576 into 10 power minus 11 Nm squared kg power minus 2. And let us now discuss what are the advantages in this Boy's experiment. We will discuss some of the advantages. So, here the apparatus size is not very much bigger, the apparatus size is very small. Therefore, the space for occupying this apparatus is very small, and also the substances due to convection currents are therefore almost negligible. So, if the size of the apparatus is very much small, the substances due to the convection currents are therefore almost negligible. So, by second advantage is you arrange the mass at different levels. Therefore, when you arrange the mass at different levels, the effect of attraction of the heavier mass on the remote smaller mass is very much reduced. And the third advantage is, by the lamp and scale arrangement, very small deflection can be measured accurately. The other important advantage is by using a quartz fiber, so this apparatus may be very sensitive and accurate. So, this comes to an end of the Boy's experiment. Next we will discuss what is gravitation field and gravitational potential. So, first let us define what is gravitation field. The space around a body within which its gravitational force of attraction is perceptible is called its gravitation field. The gravitational field is a vector quantity, or I can say it is a vector field, and therefore, each point on this vector or vector field is associated with a vector. The other important point for gravitation field is that the intensity of the gravitational field at a point due to a body is the force experienced by a unit mass placed at that point. And what do you mean by gravitation potential? The work done in moving a unit mass infinity to a point in a gravitation field is called the gravitational potential at that point. So, what do you mean by gravitation potential? By the definition, what you should do is you just transfer a unit mass from some point to the other point. So, for that you should do some work. So, and this work done in moving a unit mass is called gravitational potential, and always this gravitational potential carries a negative sign, and its highest value is being G0 at infinity, and it is the intensity of a gravitation field at a point is defined as the space rate of change gravitational potential at that point, and mathematically I can write F is equal to minus dV by dr, where dV is a small change of gravitational potential for a small distance dr. So, let us find the intensity of gravitation field at a point. So, we will discuss the gravitational potential due to a point mass. So, you consider a point A. So, you consider this a point A at a distance x. So, this is at a distance x from the particle of mass say m. This is the particle of mass m. So, all this A, x and m all lie on a same equatorial line or axial line. Therefore, the force experienced by unit mass at A is nothing but Gmm by r squared, and this can be written as Gm by x squared. So, what is the work done? So, the work done W is equal to, it is F dot dx. So, therefore, we have calculated what is F. F is Gm by x squared, and the work done W is equal to Gm by x squared into dx. So, I can write in this form Gm by x squared into dx. Therefore, what is the potential difference between A and B? So, we should calculate the potential difference. This is the at A and at B, we should calculate what is the potential difference between A and B. Therefore, the potential difference between A and B, delta V is equal to Gm by x squared into dx. Hence, the total work done in moving a unit mass from infinity is given by, you integrate this equation, you integrate from 0 to r Gm by x squared into dx. When you integrate, it is dx by x square minus 2 dx, we will get it is Gm by r. Thus, the gravitational potential has the maximum value of 0 at infinity and decreases as the distance is decreased. So, we will integrate and see, it is Gm is a constant, and you integrate from 0 to r and x power minus 2 dx. Therefore, I can write it is x power minus 2 plus 1 divided by minus 2 plus 1, or it is x power minus 1 divided by, you put a minus sign here, 2 minus 1 is 1, or minus it is 1 by x, or it is in place of x I can replace it by r, or I can write it is minus it is Gm by R. So, this gravitational potential Gm by R has the maximum value of 0 at infinity and decreases as the distance is decreased. So, let us, we are coming to the end of the session. So far we have solved a problem in gravitation. To summarize, we have solved to summarize the following points done during this lecture. I am going to give what we have done, these topics in a nutshell. First, we solved a problem pertaining to gravitation. Then we discussed about Kepler's law of planetary motion and how to deduce Newton's law from Kepler's law of planetary motion. We discussed what is gravitational potential and what is gravitation field and intensity of a gravitation field at a point. Thank you.